Alright, so this is a problem about work, and this is often a confused concept in physics because everyone wants to think of work in the sense that they think of work in real life, you know, like what's work. So the physics definition is very, very specific, and so you have to kind of forget about what you think the word work means and just consider the physics definition. So the physics definition that we're going to use is that work equals force times distance. And technically that's not exactly the full formula, but we're going to use this formula for this class. We're not going to get into it and make it too confusing. However, we are going to make sure that we know the distance must be in the same direction as the force. So we'll see what that means later on. But let's look at this particular problem. So in this particular problem, we have an object resting on the ground, and it is pushed with a force of 40 newtons, and it says it pushes that object a distance of 6 meters. And the object's 8 kilograms, so we might remember that means it weighs 80 newtons. Alright, so how much work is done here? So you might be like, well, which force am I using? I have the weight of the box, 80 newtons, but I also have the force I'm pushing with. Well, look at the direction the box is moving. The box is moving along the ground, and that's the direction we're pushing in, so that's the force we're going to use. So to calculate the work, it'll be 40 newtons, that's the force used, times the distance, the distance it moves in the direction of the push. So if I push to the right and it moves 6 meters to the right, 40 times 6, I get 240 Newton meters, and a Newton meter is just another way of saying a joule. So the work done in this problem is 240 joules. So this was F, and this was D. Alright, here is another problem. So I'm going to draw my book. I don't know why I'm drawing this in 3 dimensions. I never draw anything in 3 dimensions. But it's got a mass of 3 kilograms, which means its force downward is 30 newtons. And we are lifting this a distance of 2 meters. So this book is getting lifted upward 2 meters. Now what force are we using to lift it? Well, in order to lift the book, we're going to have to supply a force equal to its weight. It'll actually be slightly greater than its weight in order to cause it to move, but for all practical purposes, we're going to say equal to its weight. So that's the force we're applying to lift the book up. Notice the book is moving up. So work equals force times distance. So 30 newtons times 2 meters is 60 joules. That's how much work is done on the book in this situation. And here's one more scenario. I have a box that has a mass of 10 kilograms, so it weighs 100 newtons, and I am carrying this box across the room. Now, what direction is the force on the box? Well, in order to keep the box from falling, I must be exerting a force of 100 newtons upward. That's how I'm holding the box. However, I'm carrying the box 20 meters across the room. And this is where that kind of qualifying statement I made earlier is. I'm pushing and holding the box, pushing it in an upward direction. However, I'm carrying the box in a horizontal direction. So in order for work to be done, the box has to be moving in the upward direction, the direction I am pushing it. And it is not. In fact, it's not moving anywhere in the upward direction. Even if the box were moving like at an angle, there would be some work being done because the box would be moving somewhat upward. But in this situation, the box is moving completely perpendicular to the direction of my force. So believe it or not, as a result of this, work equals, the force is 100 newtons, but the distance is the distance it moves upward in the direction I push it, which is 0. So actually there is no work being done on this box here. And that's always hard for students to comprehend or really believe. Because if you've ever picked up a box and carried it across the room, you know you get tired, you use your muscles, and it feels like work. But the physics definition of work is that there is no work being done. And so it's sort of something we have to accept and move on and see how this kind of plays out down the line. But that's basically what that means. So whatever direction you push the object in, if it doesn't move in that direction at least a little bit, no work is being done. So that's it. So until next time, I am Derek Genova. Have a delightful day.